people of the world watching videos that have to do with automobiles on the internet, welcome to this. My one owner 1974 RA21 Toyota Celica ST with a Toyota V8 lurking behind that cardboard radiator. If you're new and you'd like to get caught up on this project, up above my head is either a link to the last video where I worked on it, or also could be a delicious recipe for chicken foot popsicles. Back to work. This is an accelerator pedal from a Lexus LS 430. This right here is for the drive-by-wire circuit. This sensor allows the computer to know the position of this throttle pedal and how much the user wants to give it the beans. And for those of you that know your way around a modern engine, especially a Toyota one with some Denso sensors, this might look familiar. See if I can do this without bashing my shins into the bumper support. Oh jeez. The reason why that looks familiar is because this is a throttle body drive-by-wire type. This, genuine Toyota part, is a throttle body position sensor. So that throttle position sensor, which moves the butterfly and also tells the ECU where the butterfly is, because it knows where it is, because it knows where it isn't, is the same as the throttle pedal. I need to mount this fuse where it needs to live for the rest of its life. My stomach's growling. Where are my zip ties? I had a whole bushel of zip ties and I don't know what I did with them. That is the correct measure of zip ties, by the way, bushel. Oh, this is not gonna be easy. These wires will go up the dashboard's ass. Yeah, this was almost a super expensive oops. Hope that I planned this out right. Wiring is essentially cooking spaghetti for robots. Eek! There you go. This wire is fused ignition source power that will then energize the coil in the relay to enable power to the ECU. The drive-by-wire circuit is extremely confusing but also simple. But shout out to Jimmy Oakes and Aaron from 802 Garage for making this make sense in my noodle. So I shall strip my robot spaghetti and see if Bender will throw dollar bills at it. Somebody laughed at that. Wire condom. Tech data, tech data, tech data, tech data. The other side of the drive-by-wire circuit is the plus and minus part of it, where you have auxiliary 9 and 10 that rotates the actual throttle body stepper motor, like a MA3D air conditioner. 757 steps. That technically should be shielded. Toyota shields that circuit from the factory, but nowhere in the tech data from the ECU manufacturer does it say you need to. 1 5-volt reference, 4 sensor ground. Sensor ground is green, 4 5-volt reference is red, TPS main 2, TPS sub 3, which that directly correlates to yellow. Who does number 2 work for? Spicy. Oh man, you know what I don't have? I don't have screws. Because of the fact that this is naturally aspirated and I will not be running a mass airflow sensor, MAP sensor, 1.15 bar, 1.21 gigawatts. Some of you, like myself, might be a little bothered that it uses a Deutsch connector instead of a Sumitomo or a Yazaki, but the plug is built into the sensor and it's part of my standalone ECU. I have to draw the limit somewhere, and dismantling a sensor to try to put a different style plug on it is just ridiculous. Throttle pedal. The dry erase board is more of a visual reference so I can keep track of how far along I am with the work and what I've accomplished, more so than it is an actual wiring schematic. That's all the hardware it holds intake manifold on. And just like that, the intake manifold removes off the engine. Oh, it's heavy! Underneath the turtle's belly is conveniently a space to affix hardware. And a belly button. Oh, I also got a spot right here. I don't know if it matters if I don't have it bolted in 2 spots. I don't know. Mounting this under the intake manifold is not the right move. Those 2 holes right there. I wonder what bolts there. Well, whilst I'm at it. After installing the intake manifold and torquing all hardware in the last video, I realized I couldn't install a passenger side fuel rail with the engine hoist hook installed. Sweet, and I got a spot for my harness. Washer fluid reservoir. Reservoir. This. Yeah. Wait. Cap. Yeah. So if that mounts right there, good vibrations cause sweet sensations, but bad vibrations cause your sensors to break off and bounce around your engine bay. So I'm gonna mount this to the firewall. These will go like that. And if this electrical stuff isn't enough to get you excited, I solved my cooling fan situation because I literally found a company here in Tucson that makes custom brushless cooling fans. Squish. Ta-da. Hi, welcome to the following day. I got some packages. Since the company that makes these fans is located right here in Tucson, the owner and some of the employees stopped by yesterday and brought me a bunch of their products. I literally found them by dumb luck, just searching on Google, trying to find companies that make brushless fans that would fit this narrow situation I have. And the problem with all the cooling fans that are on the market that were narrow enough to fit inside here is the motors didn't have enough cojones to actually provide enough CFM to keep this thing cool. But you can see down there at the harmonic balancer, this one clears no problem. So I have plenty of room to put two side by side in here. And because it's brushless, they built a soft start function into it. And the biggest drawback with massive power and cooling fans, oh, I'm gonna hit myself in the face, is you get this huge amperage spike when they turn on, and it blows fuses and relays and factory wiring, and it makes it hard to upgrade. So these two 10-inch fans all have 2400 CFM with only a maximum combined 14 amp draw at startup. Out. Genuine Toyota ST165 fan relay fuse box. The two OEM Denso relays inside this fuse box, one is 20 amp, the other is 30 amp. And then the third relay, the little weird beer can looking one, is a 22 amp 4-pin. Slight problem. I'm just glad I realized this now. One of these relays is not like the other. Note, dimmer relay. Yeah, I don't need to dim my fan. That's not gonna help. You see these two little tabs right here? Well, it needs to be just one tab for the beer can style fuse to fit. This is for the dimmer. Cue the shaving music. If I leave a little bit of bump, it should put some friction. So see if this will slide over. Oh yeah, it's positively locked. So that will work. Two beer cans will fit. This fuse box will live over here. Cut. EFI main relay 2 is energized by the ignition fuse. In case you didn't know, they have heat shrink for label makers, which is a total game changer for wiring. Definitely recommend. Obviously, I want to test this before I go and put it into service. Testing, coil side, testing. Has to go to one side of the coil. The ignition fuse is inside the car. Calculating distance. That should be enough to get to the fuse. Ground, power supply for the fans. That. Fan relay and EFI main relay 2 box, all in one. Speaking of box, high five. The other box the fan dudes delivered me has this little gem in it. It is a 9-inch STEELE fan, the same one I was gonna run on the MR2 for the intercooler fan, but they retrofitted one of their brushless soft start motors into that existing housing. So it's kind of neat that you can integrate a modern fan into like an older fan housing and keep the same fan shroud and stuff. What a rat's nest I've developed. It pains me that I can't loom this wiring, but I gotta make sure everything works first. I was really debating whether or not I was gonna put each fan on its own relay so I could control them individually, but that's kind of dumb. If it's hot, I just want the fans on. Oh wow, that's actually long enough to just drop right down to where it needs to go. Hello, welcome to the following day. I have a plug kit, but they're all Deutsch connectors, which are great connectors, but this is not a VW or an Audi. I can't do this. This is wrong. What I failed to explain to you, because my thought process is a bowl of jumbled wire and word soup, is that the extra relay in that fuse box for the fan, I'm gonna use as my EFI main relay number 2, which is externally mounted typically in the engine bay and is dedicated just for the ignition coils. And being that it's just the coil side of the circuit and is fused by 7.5 amps, I don't need to run an additional wire up to the car. Keep it simple, stupid. What is EFI main relay number 2, you didn't ask? I'm so glad you brought it up. It's the reason why I spent $50 on a bag full of robot snacks. And lucky for me, I got to buy these twice. The 2UZ and the 3UZ, which this intake manifold and fuel rail come from, use different style plugs for the injectors. Both Toyota Denso, but different style plugs. Let's just hope that I'm not as dumb as I think I am, and this can be salvaged faster than a robot can have a snack. Oh, that sucks. The pins are different. I literally have to redo all of these. Take note at the shape of this pin. It is ever so slightly different than this pin. And also, if that was a little too blurry and you couldn't see, I literally filmed that 7 times and I just gave up. It's so hard to focus on. That was an hour and a half of work and I turned it into 8 seconds of time lapse. Can you imagine if there was no such thing as time lapse and you had to watch for an hour and a half straight me fighting with those fucking wires? You know, it doesn't have anything to do with wires because this is a 1974. Thankfully, these were built in an era when cars were designed to last. So they're stainless. It's amazing that they can make cars affordable while using high quality materials like stainless steel everywhere. Door lock. Disconnect the lock control link rods from the cylinder and the exterior door handle. Inside this package, which came all the way from the Netherlands, is brand new genuine Toyota door lock gaskets. Could I have cut these gaskets out of a piece of scrap rubber? Possibly, but they wouldn't have been the same quality and they wouldn't have fit properly. Because I painted this with the lock out, obviously, because I'm not an idiot, there's a buildup of mils of paint inside that hole, which is preventing me from inserting the lock cylinder all the way. So I don't want to grind the paint off of that. That's a bad move. I put a little bit of cold zinc spray on it just in case. Aha! Oh, I don't like doing this part. I don't know which is worse, being a doctor that has to shove your arm up people's butts or being a human that has to shove your arm up robots' butts. I wonder if I can get through here. Oh, I started getting it. Got it. Ow, my arm. Thankfully that was the easy part. Now I just have to go through a piece of glass and get to the rod and put it on a little tiny clip that's gonna fall off and get lost inside the door. All right, I think I can do this down to the bottom. It's possible. You don't have to take the glass out. I gotta try to get this little ring and this clip on a rod up inside the door with another rod attached to it. In case you were wondering, this is not fun. Nope, it fell off. I literally don't think this is possible. I should cover this in grease. I can't see. Now I just dropped the f***ing thing. In theory, if I coat this thing in dielectric grease, it might stay put. Okay, that helped. I put a little blob of grease on these. I can't see because of a reflection of the glass. You know those situations that they say you're supposed to walk away from when you start to get frustrated? This is one of them. This is not possible. This is not possible. 30 minutes of fighting with it later. I got it. I got it. Okay. I'll take this off. I really didn't want to have to take this off again. Now I get to do this again. Yay! Ow, that's my finger! Oh, I didn't. Magic. Alright, do my door locks work? Yay! They work. Now because I want my ECU to be able to turn on the cooling fans, I need to give my ECU a way to be able to do that. An orange wire with a purple stripe must command the relay. The orange colored wires represent auxiliary outputs from the ECU, and that is a wire that is designed to switch ground. And this is the final wire right here that provides power to my ignition coils. Done. The same power supply that is powering all the injectors is also going to go to the coil of the fuel pump. Continuity check. Got the right wire. Yep, it's good. Use a little bit of solder to tap this wire into the other. Red wire, red wire. What is crawling on my back? I don't want one continuous piece of wire running from the trunk for the fuel pump relay all the way up to the EFI relay, so I got a little genuine looking plug that matches the car. This way this plug looks like it belongs in the car under the dash. I have a mission, since I'd rather set my feet on fire than do that other door lock cylinder right now. Poor truck. Well, it doesn't stink like mildew anymore. I'm pretty sure that got all cooked off. That stuff did get everywhere. So I guess when my dad hit the moose, not intentionally obviously, he had a big thing of Dunkin' coffee and it went everywhere. And there's coffee. There's coffee all over the place. That must have sucked hitting a moose and getting hot coffee all over you. It's a different plug. I need the plug for the pedal position sensor. It's 6 wires in the Tundra, but it's a different style. Toyota sensor. Hi, welcome to the 4th day in this video. I'm not losing my mind at all from all this wiring, I promise. If you're asking right now, Sarah, how much wiring do you have left on this? This is getting ridiculous. The answer to your question is, there is a total of 12 wires remaining that this engine needs for it to run. 12, and this is 2 of them. So far since I began this project, I have wired in 179 wires thus far to get to where I am. Each one requiring me to essentially learn the electrical engineering side of how that circuit functions, as well as connect little tiny pins and connectors. In addition to those 9 remaining wires on the engine, I have a few other things inside the car that need to be attached. Unfortunately, I had a bit of a smooth brain moment. I completely forgot about the courtesy lamp in the door. This was dumb. Luckily, the factory wire color is red. And just so happens I have red. Dumb to 99.9% of you, including partially myself, but I saved the original plastic that goes inside the door panel. It's not in the greatest shape, but it's not in the worst shape. It's just dirty, and I think it's cooler that this thing will still have a 50-year-old inner door plastic that survived all these years and never got thrown away. I know there's a lot of people laughing at me, but it's okay, I'm used to it. No, I am not removing the old stuff. It's oversprayed onto the door now, and that will just create more of a mess than just doing this right next to it. Now this was extremely difficult to find. It's an avocado brownish green duct tape, which was used on this car's door card originally at the bottom. And I want to put it back because that's how it was when I bought it, so that's how it shall be. Oh yeah, this stuff sticks like it's 1970. The driver's side door is now ready 100% for final assembly. Wiring in here, 90% done. Wiring in the engine bay, 95% done. The next video you see on this car, I'm going to apply power to the ECU, hook it up to a laptop, and start seeing some life hopefully in the engine. And then mechanically, I have to make fuel lines, clutch line master cylinder, hook up an external oil cooler and filter housing, and measure for a serpentine belt. And then mechanically, it should be ready to try to crank. So, getting there. Thank you guys for watching. I'll see you soon with another video. Bye.